Similar to the previous thermodynamic properties we defined previously, the standard change in Gibbs free energy for any reaction is defined as the free energy change for the reaction when it occurs under standard state conditions, which means under standard temperature and pressure, and also using standard states of the substances, whatever physical states they are. And in this case, the standard delta G of any reaction is going to be, again, delta G of formation of the products minus delta G of formation of the reactants. So it's the same math as delta H and delta S for any reaction. And it's based on defining the standard free energy of formation for any substance to be the change in free energy during the formation of 1 mole of the substance from its elements in their standard states. Similar to delta H, we will selectively choose to make the delta G of formation for any element in its most stable form to equal 0 at 25 degrees and 1 atmosphere. Using this selective reference point, we can do calculations to calculate the change in free energy for any reaction using the products minus reactants math. So for this reaction right here, if we want to calculate delta G for the reaction, is going to equal the sum of number of moles times delta G of formation of the products minus the sum of number of moles times delta G of formation of all the reactants. So it's going to equal CO2, which is negative 394.4 kilojoules per mole, plus 2 times delta G of formation of water, which is negative 237.2 kilojoules per mole, minus all the reactants, which is gonna equal delta G of formation of methane plus delta G of formation of oxygen times the number of moles of oxygen, which is 2, but this value is going to be 0 anyways because oxygen is an element in its most stable form. So as we said, we selected to make delta G of formation of elements to equal 0, which is going to give you negative 818 kilojoules per mole. This choice right here.